Hello everybody. So today we're going to review for the chapter 6 test. So let's go ahead and get started. Number 1, I'm on page 271. For numbers 1a through 1d, tell whether the fractions are equivalent by selecting the correct symbol. So remember, that means equal and this is not equal. All right, so when we're comparing these, we're going to use the different strategies we've learned through this chapter. And so this one, I'm going to look at the fact that these are both, that this is in simplest form, the 1/4. So I'm going to multiply 1/4 by a factor that will give me a common denominator of 16 sixteenths. So 4 times 4 is 16. So 4/16. So yes, those two are equal. All right. 5/6 and 25/30. 5's prime, so this is in simplest form because 5 is not a factor of 6. So can I multiply 5/6 by something to get 30ths? Yeah, 5. 5 times 5 is 25. So 5/6 is equivalent to 25/30. 3/5 is prime. 3 is not a factor of 5. 5 is not a factor of 3. So can I multiply 3/5 by something to get 15ths? Yeah, 3. 3 over 3. 3 times 5 is 15. 3 times 3 is 9. So 9/15 is equivalent to 3/5, but 9/15 is not the same as 12/15. So these two are not equal. 6/10, 5/8. Well, can you multiply 5/8 by a whole number or a factor that would give you tenths? No. Can I multiply 5 by anything to get 6? No. So there's no way we can get 6/10. Okay. Number 2, Juan's mother gave him a recipe for trail mix. All right. And so those are the measurements for the trail mix. And it wants us to order the ingredients from least to greatest. All right. So we have to compare 3/4, 1/4, 2/3, 1/2. All right. Well, this one here is less than a half. Half of fourths would be 2/4. So the others are half or greater than a half. This is greater than a half. This is greater than a half. So half is next. And now we have 2/3 and 3/4. Well, here, let's go ahead and find a common denominator by listing factors of 4 and 3. 3, 6, 9, 12, 15. I'm going to stop there. 4, 8, 12. All right, so 12. So 3/4 times 3 would give me 12ths. So 9/12. And 2/3 multiplied by 4 gives me 8/12. Because 2 times 4 is 8. And 3 times 4 is 12. So 3/4 is slightly bigger than 2/3. Order the ingredients. 1/4 cup peanuts, half cup raisins, 2/3 cup almonds, and 3/4 cup cereal. All right. Taylor cuts a fifth sheet of construction paper for an arts craft project. Write 1/5 as an equivalent fraction with the denominators shown. Okay, so if we start with 1/5 and then we multiply that by 2, we would get 2/10. So this one must be 2/10. Then if we take 1/5 and multiply by 3, we get 3/15. Okay. And 1/5 times what would give me 20/5. 5. 5 times 5 is 25. 5 times 1 is 5. So 5 25ths. And 1/5 times what gives me 40ths. 5, 10, 15, 20, 25, 30, 35, 40. 8. 8 times 1 is 8, so 8 40ths. Okay, simple enough. Number 4. A mechanic has sockets with the sizes shown below. Write each fraction in the correct box. So which ones are less than a half, equal to a half, and greater than a half? Okay, so less than a half would mean that, like this one here, is greater than a half. 4/8 is half of 8ths, and 7/8 is bigger. 3/16, half of 16 would be 8. So this one has to be less than 1/2. 1/4, half of 4 is 2. So this one has to be less than 1/2. 3/8, half of 8 is 4. So this one's less than 1/2. 4/8, that is 1/2. And 16, again, 8/16 was half, so that one's greater than 1/2. So which ones are less than 1/2? Well, we have 3/16, we have 1/4, and we have 3/8. Which ones are equal to 1/2? Just 4/8. Which ones are greater than 1/2? 7/8 and 11/16. So let's see, 1, 2, 3, 4, 5, 6 fractions I've written. 1, 2, 3, 4, 5, 6, and there were 6 that we had to place. Okay? So not every box is going to be used. Okay. Number 5. Darcy bought a ½ pound of cheese and 3/4 pound of hamburger for a barbecue. Use the numbers to compare the amounts of cheese and hamburger Darcy bought. Okay. We're comparing a ½ pound of cheese to 3/4 pound of hamburger. So I don't need to find a common denominator because 3/4 is greater than a half. Half of 4 is 2. So 2/4 is smaller than 3/4. And 2/4 is 1/2. So we're going to say 1/2 is less than 3/4. All right. 6. Brad is practicing the piano. He spends 1/4 hour practicing scales, a third of an hour practicing the song for his recital. For numbers 6a through 6c, select yes or no to tell whether each of the following is a true statement. 12 is a common denominator of 1/4 and 3. Well, if you're not sure, remember we're going to list factors, multiples of 3. 3, 6, 9, 12. The reason I stopped at 12 is because that's what they're asking us, is that in common? 4, 8, 12. Yes, 12 is in common. The amount of time spent practicing scales can be rewritten as 3/12. Well, what's a common factor for 3 and 12? 3. Okay, so I can divide both of them by 3. I would get 1/4. So practicing scales is 1/4. It can be written as 3/12 by multiplying by 3. The amount of time practicing the song for the recital can be rewritten as 6/12. Practicing the song for his recital, 1/3 times what would give me 12ths? Well, if I multiply both of them by 4, I could turn the thirds into 12ths. And that would give me 4/12. 4/12 is not 6/12, so no. 7. In the school chorus, 4/24 of the students are 4th graders. In simplest form, what fractions of the students in the school chorus are 4th graders? So simplest form, we want to reduce the fraction until either both the numerator and denominator are prime numbers, or you just can't make it any smaller. So we're going to start by listing the factors of 4 and 24. I'm going to start with 4 because it has the least amount. And we just have to find something that's in common to both of them. 1 and 24. Okay, but remember, if I divide it only by 1, it's already simplified then. If only 1 is a factor. 2 goes into 24, 2 and 12. Okay, so I could divide by 2. 3 and 8 are factors of 24. Oh, but so is 4 and 6. So let's divide this by 4. 4 divided by 4 is 1. 24 divided by 4 is 6. So 1/6 of the students in the school chorus are 4th graders. Which pair of fractions are equivalent? Mark all that apply. All right, so I'm going to take the number that's in simplest form, 2/3. Can I multiply that by something to get 12ths? Yes, 4. 4 times 2 is 8. 4 times 3 is 12. 8/12 is 8/12. 3/4 and 20/28. 3/4 times what would give me 28ths? 4 times 5 is 20. 4 times 6 is 24. 4 times 7. So let's multiply by 7. 4 times 7 is 28. And 3 times 7 is 21. 21/28 does not match 20/28. So those are not equivalent. 4/5 and 12/16. That's not going to be possible. 5 can never become 16. So I'm not even going to do that math. Yeah, what you could do is go 4 times 3, because that would be 12. So the numerators would match. But 3 times 5 is 15, not 16. So no. And 7/10 times what would give you 30ths? 3. 10 times 3 is 30. 7 times 3 is 21. So those two do match. So they're equivalent. Number 9. Sam worked on his science fair project for 1/4 of an hour on Friday and half an hour on Saturday. What are 4 common denominators for the fractions? And explain your reasoning. Common denominators for the fractions. So we're comparing 1/2 and 1/4. So we need to make a list of multiples for 2 and 4, and we need to find 4 multiples that are the same. So 2, 4, 6, 8, 10, 12, 14, 16. I'll stop there. That's 8. Let's see. 4, 8, 12, 16, 20, 24. Let's see how many we've got in common. We've got 1 right there. 1, 2, 3, and 16. What are the 4 common denominators? 4ths, 1/8, twelfths, sixteenths. Fourths, eighths, twelfths, sixteenths are common denominators. Explain your reasoning. 4, 8, 12, 16 are multiples of both 2 and 4. Marita works in a florist shop and makes flower arrangements. She puts 10 flowers in each vase, and 2/10 of the flowers are daisies. Okay, so if Marita makes 4 arrangements, how many daisies does she need? Okay, so we could use a table for this, right? So let's try that. Arrangements, and in their arrangements we have daisies over total flowers. Daisies over total flowers. So in one arrangement, I would have 2/10. In 2 arrangements, I would have 4 daisies out of 20 flowers. In 3 arrangements, I would have 6 daisies out of 30 flowers. Out of 4 arrangements, I would have 8 daisies, 40 flowers. Okay, I can stop there because it says 4 arrangements. How many daisies does she need? She's going to need 8 daisies. Okay, so show how you can check your work. Well, I can do this. 1/2. No, 1/2. I was just looking at the arrangements in the daisies and said 1/2. No. 2/10. That's how much was needed for 1. And then for 4 arrangements, it would be 8 40ths. So okay. So that's how it checks. Okay. So I listed a table, and all we did was count daisies. So in 1 arrangement, there was 2 daisies. In 2 arrangements, there would be 4. In 3, there would be 6. In 4, there would be 2. So basically, we're just multiplying the number of arrangements by 2. Last weekend, Marita used 10 daisies to make flower arrangements. How many flowers other than daisies did she use to make the arrangements? Last weekend, she used 10 daisies to make flower arrangements. How many flowers other than daisies did she use? Okay, so we can use, let's extend our table out here. And I'm just going to draw an arrow from this box to this to show that I'm making one more arrangement. Okay, so if she used 10 daisies to make flower arrangements, she made 5 flower arrangements. How many flowers other than daisies did she use to make the arrangements? 50, take away 10, 40 other flowers. So take 50 total flowers and subtract 10 daisies. to get 40 other flowers. In Mary's homeroom, 10/28 of the students have a cat, 6/12 have a dog, 2/14 have a pet bird. For numbers 11a through 11c, select true or false for each statement. In simplest form, 5/14 of the students have a cat. Have a cat. So 10/28 have a cat. Okay. So 10/28, we need to find a common factor for 10 and 28. So let's list the factors of 10. 1 and 10, 2 and 5. All right, 28. 1 and 28. I know 2 is a factor because 28 is even. And 2 times, well, if we're not sure about that, we can quickly divide. 8, 1 shared with 2 groups is 4. So 2 and 14. 3. No, because 8 plus 2 is 10. 10 is not divisible by 3. 4. I know that's a basic math fact. 4 and 7. 5, no, because it doesn't end in a 0. 6, no, because it's not divisible by 3. 7, we know. 8, 16, 24, 32, no. So those are the factors of 28. Now, what's in common to both 10 and 28? Well, 1 is. That's not going to help us any. 2 is. So we've got to divide by 2. 10 divided by 2 is 5. And 28 divided by 2 is 14. So yeah, 5/14. In simplest form, 2/4 of the students have a dog. Well, first off, 2/4 is not simplest form. If I was doing 6/12, I'd have to list the multiples of factors of 6, which would be 1 and 6, 2 and 3. And 12 would be 1 and 12, 2 and 6, 3 and 4. So the greatest factor would be 6. So if I divided that, that would be 1/2. So no, that simplest form is not 2/4. Simplest form is 1/2. In simplest form, 1/7 of the students have a pet bird. Well, let's see. 2/14 have a pet bird. I know the only factors of 2 are 2 and 1, and 14 is divisible by 2. So 2 divided by 2 is 1. 14 divided by 2 is 7. So 1/7 in simplest form. Yes. Number 12. Regina, Courtney, and Ellen hiked around Bear Pond. Regina hiked 7/10 of the distance in an hour. Courtney hiked 3/6 of the distance in an hour. Ellen hiked 3/8 of the distance in an hour. Compare the distances hiked by each person by matching the statements to the correct symbol. Each symbol may be used more than once or not at all. So if I was comparing these 3 numbers to a half, this one is greater than a half. This one, less than a half. Right? Because half of 8 is 4. 3/6, half of 6 is 3. So is 1/2. Okay, so I know that the largest one is 7/10. The smallest is 3/8. And in the middle is 3/6. So 7/10 is greater than 3/6. 3/8 is less than 3/6. 7/10 is greater than 3/8. Could have also found a common denominator if you wanted, but this one made a lot of sense just to compare it to the benchmark 1/2. 13. Ramon is having some friends over after a baseball game. Ramon's job is to make a vegetable dip. The ingredients for the recipe are given below. All right, so we know that these are the ingredients, and they're all in cups, and they're all less than 1 whole, so they're fractions of a whole. Which ingredient does Ramon use the greater amount of? Buttermilk or cream cheese? Okay, so we don't need to worry about anything that's not buttermilk or cream cheese. Buttermilk is 5/8 cup. Okay, buttermilk. Cream cheese is 1/2 cup. Well, compare to benchmark, right? What's 1/2 of 8? 4. 4/8 is smaller than 5/8. 4/8 is equal to 1/2. So 5/8 is what they used the most of. He used more buttermilk. 5/8 is greater than 4/8 or 1/2. Ramon says that he needs the same amount of 2 different ingredients. Is he correct? He needs the same amount of 2 different ingredients. Well, so they're asking us to find equivalent fractions. I see nothing else that's 1/2. Okay, so it's not cream cheese that they're talking about. 1/16. Well, that's prime. So nothing's equal to that because there's no numbers bigger than 16ths. Okay, so it's not lemon juice. 5/8. If I double that, that would be 10/16. And I can't make it any smaller because 5/8 is prime. 5 is prime. 6/8. Look at those two right there. Okay, so the ingredients are scallions and parsley. 6/8 equals 3/4. Right? If I take 3/4 and multiply by 2, I would get 6/8. Or if I took 6/8 and divide by 2, I'd get 3/4. Either way. 14. Sandy is ordering bread rolls for her party. She wants 3/5 of the rolls to be whole wheat. What other fractions can represent the part of the rolls that will be whole wheat? Shade the models to show your work. 3/5 of the rolls. Okay, and then it's then saying take those 3/5 and turn it into 25 pieces. 5 times what is 25? 5. So we can make 5 vertical sections. 5 vertical sections, that gives us 25. And 3, 6, 9, 12, 15. All right, what's another one we could do? Well, so these are okay, so I'm starting with the 3/5 again. And I just need something that I can multiply the 3/5 by. Why don't I just double the 5? So instead of having 5 pieces, I have 10 pieces, 10 total parts. And out of that, 1, 2, 3, 4, 5, 6 are shaded. Okay, so this is a possible answer. You could have had 9/15. You could have had 12/20, 18/30, so on. Okay, so this is just one possibility. I just took the smallest one. All right. Angel has 4/8 yard of ribbon, and Lynn has 3/4 yard of ribbon. Do they have the same amount of ribbon? 4/8, 3/4. Shade the model to show how you found your answer. All right, so Angel's ribbon is 4/8. 4/8. Lynn has 3/4. Okay, so do they have the same amount of ribbon? No. This one's half. This one's past it. This one's greater than 1/2. No, they do not have the same amount. Four eighths equals 1/2, and 3/4 is greater than 1/2. 16. Ella used 1/4 yard of red ribbon, filling each box with a number from the list to show equivalent fractions. Not all numbers will be used. All right, so here, what did they multiply the fourths by to get eighths? 2, right? So 1/4 times 2/2 would give me 2/8. 2/8. Now this next one, if we have 1/4 to start, and then my numerator is 4, I have to multiply by 4, because 4 times 1 is 4. 4 times 4 is 16. All right, so 4/16. Now, we have to see which ones would work next. So here we've multiplied by 2/2, 4/4. Let's try 3/3. Let's multiply it by 3. That would give me 3/12. Are those options? Yes. So I can put 3/12 there. All right. How about 1/4 times 5/5? That would give me 5/20. Well, there's not a box for it, but 5/20 does work. Okay. If I multiplied 1/4 by 6, that would give me 6/24. I don't see a 6/24. So if we use 3/12, 5/20, 6/15, we're not going to use. All right. So I guess this is one possible answer. If we are looking at as far as like a pattern, 1, 2, 4, it probably wouldn't be 3. It would probably be the 5/20 instead. But they are both equal to 1/4. Okay, so fill in each box with a number from the list to show equivalent fractions for 1/4. Okay. 17. Frank has 2 same-size rectangles divided into the same number of equal parts. One rectangle has 3/4 of the parts shaded, and the other has 1/3 of the parts shaded. Into how many parts could each rectangle be divided? Show your work by drawing the parts of each rectangle. All right, so we have 3/4. Didn't make that quite equal, did I? What am I doing? Ignore that box. I'm going to have to draw another box. All right. So 3/4. All right. And 3 of them are shaded. All right. So that's what I should have done for the 3/4. So 3/4 and then 1/3. Okay. So if we found a common denominator, that would tell us how many parts they could both be divided into, right? So 1/3 and 3/4. So what could we break that into? Well, this has 4 sections. This has 3 sections. What if I took this and broke it into 3 sections that way? And this one, if we broke it into 4 sections, like that. Well, now I'd have 3, 6, 9 twelfths. And here, 4, 8, 12, we'd have 4 twelfths. Okay. So how many parts could each rectangle be divided into? 12 parts. Is there more than one possible answer to part A? Well, yes, because if we took fourths and thirds and listed common multiples, we would see that 24ths are also in common. So yes, because the common denominator for 3/4 and 1/3 is also 24ths. All right, 2018. Suki rode her bike 4/5 mile. Claire rode her bike 1/3 mile. They want to compare how far they each rode their bikes using the benchmark 1/2. For numbers 18A to 18C, select the correct answers to describe how to solve the problem. Compare Suki's distance to the benchmark. 4/5. Well, half of 5, we've said, is 2.5. This is bigger than 2.5. It's 4. So that has to be greater than 1/2. Claire's distance to the benchmark, 1/3. Half of 3 is 1.5. So this one is less than 1/2. So if Suki's was greater than half and Claire's was less, Suki rode her bike a longer distance. So that's it for chapter 4. Chapter 6, make sure you practice your skills, re-look at problems that were difficult for you, and good luck on your test. I'm certain you're going to do well. So until then, may the numbers always be in your favor.